All right, so we're going to talk about conditional probability. And the way that we're going to note that is going to be the probability, and it's going to look like this, and that's a vertical bar, okay? So the way I read this is the probability of A happening given that B has already happened. Okay, so it's a conditional probability. And I can also flip it. I mean, there's no magic about the variables or the letters that we're using. So I could say the probability of B happening given that A has already happened. So whatever you see last, we already know. It's already been established. It's already there. Okay, joint probability. If you think about joining two things together, it's what they have in common. So it's going to refer to the intersection of two things. So go back to the Venn diagram. It's going to be that little middle part. And I'm actually just going to explain the thing in the book simply because I don't feel like making up my own numbers. So math people are lazy, remember? All right, so what they've talked about is police force. So it's a promotion status of police officers over the past 2 years. So we've got male police officers, we've got female police officers, and then we've got officers that were promoted versus officers that were not promoted. So I can look at this two ways. I can look at columns. So I've got 288 men here and another 672 men here, which means I'm dealing with 960 men. And then same thing, 36 women, 204 women, means that is not 24, Atlantic Ocean, 240 women right there. Now, I can also look at it horizontally or by row. So how many are promoted? Well, these people were promoted and these people were promoted, which means a total of 324 people were promoted. These ones were not. So these people were not promoted, these people were not promoted, and that's a total of 876 people that were not promoted. Now the cool part is if you add across, so here are all the men and all the women, we got 1,200 people. If you view vertically or row by row, then we're looking at the promotions. So these people were not, or these people were promoted, these people were not promoted. So when we talk about promotion status, we're talking about 1,200 people. Another thing to look at is we could look at these as complements. So if I'm talking about whether or not you were promoted, that is a one or the other thing. Okay, so if promoted is event A, then, well, if you didn't get promoted, or I'm sorry, if you did get promoted, you're in event A. Well, the complement of that must mean you haven't been promoted. So those two things added together are 100%. So these two things are complements. These two things are complements. Now what we're going to do is we're going to put this into a frequency table. And I am just going to take this as parts out of the total. So I notice that this portion of men, okay, is out of 1,200 total. Okay, so I'm going to do 288 divided by 1,200. And when I do that, I get 0.24. Okay. So 288 out of the total. So 288 out of the 1,200 gives me a 0.24. If I do 672 out of the 1,200, so divide those two numbers, I'm going to find out, and again, I'm just looking at the book, that this is 0.56. Okay, so these are proportional out of the whole. So I know that these two amounts, about 24% of men were promoted. Okay, out of the 1,200. So look at the women, and when I do those, I get 0.03. And notice I'm working from the inside out this time. So I fill in these first. I fill in these boxes first. And now I can total again, going vertically and going horizontally. So when I add 0.24 and 0.03, I find out that there's a 27% promotion rate, regardless of who I promoted. Okay, when I look at this way horizontally, 56 and 17 is going to give me 673. So I get 0.73. Okay, so 27% are promoted. Well, the complement is not promoted. So it must be 73%. Well, guess what happens when you add those together? You get the total. So my total here was 1,200. Well, my total here is 100%. Okay, or 1. Well, now I can add these and figure out how many were men. So I've got 2 and 5 is 7. That gives me 80. Okay, so add those together and I get 0.8. So of what I was considering, 80% of the population was male. Well, when I add the 3 and the 17, I get 0.20. So 20% was female. We'll add those together and you get 1. So these are called joint probabilities because two things have to occur for these to be in the probability table. So you have to be promoted and a man in order to be here. So the word and is there, so that's intersection. So these occur jointly, so this is joint probabilities. Okay, I have to be a woman and not promoted. Well, 17% of those occurred out of the total. Okay, so those are joint probabilities. So I'm going to shade these kind of. The interior boxes are your joint probabilities. Okay, they are men and promoted, men and not promoted. Okay, the outsides are in the margins. So we call those marginal probabilities because literally they're in the margins. So the insides are your joint probabilities. And the outside, so the 0.8, 0.20, 0.73, and 0.27, those are called marginal probabilities, literally because they're in the margins. Okay. So I can look and answer all these things and put them in the symbolism that we were using before. So the probability of being a man and being promoted. So look at men and promoted, and that's going to give me 0.24. So I can get these probabilities based on just looking at the table. Well, that takes us to conditional probability. And I'm literally going to show you the book here because it's easier for them to do it than me. So if I look at this, pardon me while I plop this everywhere. Okay, if I look down here at this cool little Venn diagram, a conditional probability, so what this says is the probability of A happening given that B already did. So we know beyond the shadow of a doubt that B happened. Well, knowing that, what's the probability that A is going to happen too? So what we're going to look at is this formula is the probability of A intersect B, so their intersection, and then divide out the probability of B. Okay, and that's going to leave the probability of A given that B has already occurred. And you'll notice in your book it's already up here too. So what does that mean? What does that look like? Okay, so I can look and we can formalize this. So if I want to say the probability of A given that B has already happened, I'm going to write that as the probability of their intersection. So A intersect B, and then divide out just the probability of B. Okay, so divide out the probability of B. Now I can flip-flop all of my variables around and say the probability of B given that A has already happened. And guess what? It's their intersection. That's not an N, sorry. That's intersection. And then divide out the probability of A already happening. Okay, so in other words, what you're actually asking is something like, what's the probability of a promotion if I already know that the officer is a man? Okay, so what's the probability of a promotion given that the probability is a man? Okay, so here's what that's going to look like. I was trying to take notes a different way. Okay, I can look at this and pull those values, but hang on, back up. Back the truck up. Instead of doing all of these frequency tables, a lot of times it's going to be given to you. So the probability of A given B, you will know these probabilities. Now, what we do need to look at is the multiplication law, okay, because that's going to help us figure out what's going to happen if we do need to backtrack and if we do need to find an intersection or something like that. So using what we know from here, okay, if I want to know the probability of just the intersection, so remember this is just a number and this is just a number. Well, if I want to know just the intersection, I can multiply both sides of the equation by the probability of B. Okay, so I'm going to use, give me a different color pen. I'm going to use, are you red? You are red. Okay, if I want to know what just this is, I can multiply both sides by the probability of B. Okay, it reduces over here because any number divided by itself is 1. So if I want just the intersection, all of a sudden I've got a multiplication problem. I can take the probability of B happening times the probability of A given B happening. That will give me the answer for the intersection. So it looks very convoluted with all of the parentheses and vertical lines and all that kind of stuff. You just got to remember these are just numbers. Okay, and worst comes to worst is you can come back here and recognize this is an intersection. Okay, and if I want the probability of a promotion, okay, well, there's the probability of my promotion given that the probability of being a male. Okay, so you can work backwards and find these numbers from a relative frequency table. Now, we also have a multiplication law for independent events. Okay, meaning that they do not overlap. Okay, so there's a difference. What we have is mutually exclusive, which we addressed in the last video, and then we've got independent and dependent. Okay, these conditional probabilities are set up to say, well, I'm looking to find out what the probability of A is, and that's dependent on if B has happened. Okay, so these are dependent issues. You can also have independent issues. And if that's the case, the probability of the intersection, since they are independent of one another, you're going to have the probability of their intersection being simply the product of their probabilities. Okay, and now notice the difference. Okay, so over here, we had to go through and multiply both sides by the probability of B. Okay, look down here. I could have multiplied here by the probability of A, so let's do that for a second. Multiply by the probability of A. Any number divided by itself is 1, so now I've got the intersection problem. Okay, if they are independent events, then what you're going to notice is that their intersection is not going to have this dependency in there. Okay? And so you're just going to kill the dependent part, and you'll find out that their intersection is just the probability of A times the probability of B. In other words, there's no stipulation at the start. Okay? So what this says, the way you interpret this, is the probability of something happening given that I know something else has already happened. Independent events simply mean I don't care about about this restriction right here. Okay, so now we have those formulas to go through. So now you have 4.4. In 4.5, we're going to talk about Bayes' theorem.